Welcome to one more video where I want to talk more about triple integrals. Seems like many people stuck with this homework problem where they ask to evaluate triple integral where E, which is basically the domain, we evaluating triple integral over E, is a solid tetrahedron with given vertices. Let's speed up a little bit because it's a pretty long problem and I really want to go take a nap, so let's do it fast. Let's see. This is my sketch or picture I totally stole from the internet of tetrahedron. And for example, this is my 0, 0, x, y, and obviously up is going z. So we're trying to find bounds for x, y, and z as always. We're trying to figure out between what those variables will be in the triple integral. So the inside of the integral the integrand will have to wait. But for now, if it's dx, dy, dz, what should I put here, right? So let's see. It would be nice to build the equation of the plane. And I like, oh wait, tetrahedron is on the floor. So the most obvious equation of the plane will be the floor. This plane, let me call the points A, that's 0, 0, 0. B, that's 7, 0, 0. C, that is 0, 7, 0. And up, well, okay, and then 0 is over here, obviously, like this, but whatever. And up it is D, 0, 0, 2, like so. So I can just write down the equation of these three right away because they are on the floor. They're not lifted. The equation of this plane will be z equals, what do you think? Correct, it is z equals 0 because there's no height, right? It's on the floor. Well, does this give me like any kind of hint? No, so this was like completely useless, waste of time. We need another plane. So this is how I was thinking about it, especially I was thinking how to explain it well. I can just fix one variable, either x or y or z, to be a constant, okay? That will be the one on the very far to the right of the integral. So if I fix x to be running from 0 to 7, how do I know it's from 0 to 7? Because of these guys, right? So I will just write down x is from 0 to 7. At least I have now one variable done. It's from 0 to 7. Now all others will not be from constant to constants. They will be from a function to a function. How do I know? Because y from at this place hits to this line, and then to this place it hits another line. Same with z. It hits this plane that's looking towards you at some places, and it hits this plane on the other places, and there's also like a backside and whatever. So these will be some kind of equations, although I can see that they will be from 0 to something. So at least that is not so bad. They all start from 0. As you can see, even from variables, y starts from 0 and z starts from 0 all the time. Okay, so let me put these. Now I want to build another plane through any other points. So for example, well, let me, I guess, do steps. Step 1, we fixed that x is from 0 to 7. Step 2, let's build the plane. Equation of the plane through any other 3 points. So I will do B, C, D, like this. Some people even put like a line on top of those. And let's do this. We have so many videos about how to build the equation of the plane through 3 points. We need first to have 2 vectors, AB, there's no AB here. So we're gonna do BC and BD. You can do any other 2. I will do BC and BD. So let's quickly build them. Those are vectors, don't forget. Second minus first, so I'm erasing this, and I'm looking at BC. 0 minus 7 is minus 7. 7 minus 0 is 7. 0 minus 0 is 0. And then with D, it's going to be 0 minus 7 minus 7. 0 minus 0 is 0. 2 minus 0 is 2, like so. And now you start calculating I, j, k minus 770 minus 702 determinant to find n, right? And that's gonna go into the equation. So of the plane through via 3 points. And you know what to do. I goes first, then cross product gives me 14 minus 0, minus j gives me minus 14 minus 0, plus k, I, j, k are vectors. K is 0 minus 49, so it's minus 49. So it's plus 49. So that can be written as 14, 49, and that is my n. What is n? Normal vector sticking out from the plane. So it's the tilted plane, as you understand. I used CBD plane points over here, so this is the plane. Okay, equation of the plane. That's what you need to know for sure, really well. It is ax minus x sub 0 plus b, y minus y sub 0 plus c, z minus z sub 0 equals to 0. Or there's also another equation including d, and there's also another equation, blah, blah, blah. Just know at least one of those. They all are the same. A, B, C are components of the normal vector. So let's put it there. The equation becomes A is 14x minus, let's choose B. Any point will work, but B, I kind of like that. So I don't remember it, that's the problem. B 700. So 7 is here. Plus 14y minus 0 plus 49z minus 0 equals to 0. That is the finished equation of the plane through 3 points. I can rewrite it if I want, like I can divide by 7, for example. And that's going to be 2x minus 7 plus 2y plus 7z equals to 0. I kind of like this form better. And I can also simplify it if needed. It's going to be 2x plus 2y plus 7z equals 2 times minus 7 is minus 14, so 14. That's, I think, is the best version of it. And if you really want to, I could divide both sides by 14, and that's probably what you see some students writing this kind of solution. If you divide by 14, you will have x over 7 plus y over 7 plus z over 2 equals to 1. And that's not my favorite one. I like the previous one better. Okay, good. So I'll be using the previous one. Why? What is the next step? We build the equation of the plane. Now what? Well, now we can actually start building the integral. And then the last step will be to actually integrate. So we have integral, have some space between them, integral. The inside part, don't bother about it right now, is is xy. And then any order you want, but since the x is at the end, let's do dz, dy, dx, just be consistent. If x is the last one have to be integral full of constants, which means lower and upper limit of integration should be constant. Because then we're not going to have definite integral should have a number as the answer. And we're looking for the what? We're looking for the triple integral, right? So in this case, representing the volume and stuff. So it should be a number. Anyway, how to figure out from this equation that I was going to call star, limits for other variables? Very easy. You just solve for them. So remember, until you go to this last step, everything is in 2D because it's x and y. There is no height. If there is no height, which is in this case third dimension, which is in this case z, right? Then z equals to 0 over here. Watch all my previous videos, or at least some of them, where I describe how to write down all versions, dz, dy, dx, dz, dx, dy, dx, dz, y, and so on. There's 6 versions, right? So if z is 0, Then let me put like a wiggly line. From the equation star, I will have 2x plus 2y equals to 14, which is x plus y equals to 7. This is what's happening on the floor, on the xy plane. X plus y equals to 7. It's a tilted thing, right? So from here, we can write down that x is 7 minus y, and y is 7 minus x. Like so. And that will be my upper limit for x. Well, for x, we already figured out it's a constant, so we're not going to do that. We already learned that. I will show you right now why. But for y, this is my upper limit. So I'm going to put in green. From 0, y goes from 0 to 7 minus x. Y equals 0, y equals 7 minus x. And we can now check if y is 0, over here, x is 7, matches. If y is 7 minus x, and we're going to plug here 7 minus x, 7 and 7 cancels out, x becomes x, so that matches too. 0, 0, 7, 7. So that's good. Now the z is the ones left. Well, for z, you just solve the same equation just for z. Let me put it in some kind of purple color. From the star, again, I will do the arrow like this. That means then. If you don't know, that's my then, the arrow. Z can be calculated as, so let's just divide everything by 7, right? It's going to be 2 minus, so 2 minus 2x over, I can factor out, I guess, 2 or 7. I can factor at 1/7. Maybe that will be easier. So 7z equals 14 minus 2x minus 2y, right? So kind of simplifying is not very nice. Maybe I just factor out 7. Oh, but then 14 would be nice. Okay, fine. Let's just write down. It's going to be 2 minus x over 7 minus y over 7. That's it. That's what I got. Do you agree with that? Let me check with my notes. 2 minus, I think it's, oh, I missed 2. Yeah, I see something is wrong. Did you notice? 2 is still here. I don't know why I simplified 2. Okay, good. Don't make a mistake. Well, if you did make a mistake, it's fine. You'll just suffer integrating stuff and then everything will be wrong. So just catch it as early as possible. So z is from 0 to, then like it's not even looking nice. I guess let's factor out 2. Z is from 0 till 2, and it's going to be 1 minus x over 7 minus y over 7, like so. 2, 1 minus x over 7 minus y over 7. That's what I stuck with, like what is better to factor out. So here you go. This is my triple integral. Yay, we just spent so much time just creating it. Step 4, actually integrate it, right? So let's start and hope for the best. It looks very not nice, but who knows? Let's stay optimistic. So I'm not touching the first 2, 0, 7. Remember, if limits of integrations are not constants, you cannot change the order. Only when they are constants, you can change the order of integration. In this case, we're stuck with integrating with respect to z first, which is kind of nice because x times y is a constant. With respect to z, we will have x times y times z, right? Then there's a bar, and we'll have 0 and this 2, blah, 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 which I'm going to erase and just plug, instead of z, I'll change the color for you into red to be consistent, 2, 1 minus x over 7 minus y over 7, like so. And now we have dy dx. So you see there was a bar with 0 and this equation of the line. So equation of the plane. So what I did, I just plugged the equation right away. ignore this 0. Make sense? Now, second step is integrating with respect to y, but now there's several y's. I guess let's distribute. Should work, right? Like again, so let's stay optimistic. Let's just distribute everything. Equals 0 and 7 are waiting, and I'm distributing before integrating. Oh, that's a rhyme. That's nice. So we have 2x y minus, should I? Yeah, let's distribute everything. Minus 2x squared y over 7 minus 2xy squared over 7. I think I did correctly. Parentheses dy dx. Wow, such a nice example. At the end, we're going to do U-substitution, by the way. So let's integrate from 0 to 7. We're integrating with respect to y, which means everywhere you see y, that is the variable. Everything else is a constant. Luckily, y only shows up once in every piece, so that's actually not too bad. 2x stays as it is. Y becomes y squared over 2. 2 cancels out with 1/2. Minus 2 over 7x squared stays as it is. Oh, couldn't we just like collect those two terms? Well, kind of dumb, but okay, yeah, I should have collected them. Y squared over 2, and then cancels out with 1/2. I will collect them right after this. Minus 2 over 7x, and this one is in blue, y cubed over 3. But that is not the answer, right? We have a bar from 0, and then y equals 7 minus x. And the last is dx. Sometimes students tend to get confused. 7 minus x, where do we plug it? What if we have like k over here, like some constant, or like mu, some kind of gravitational constant, or density and stuff like that? In this case, people like to sign that y is 0, y is 7 minus x. So 0 is 0. I will just keep that. Luckily, everything gives me 0 when y is 0. So I'm only need to plug the top, which is 7 minus x. I mean, sure, let's do that. Let's not touch x. So let's combine those two. I will put them a different color. Let's combine those two terms because they have the same variable y squared, right? So it's going to be 2 canceled out. It's going to be x minus 1 over 7 times y squared, right? But instead of y squared, I'll put it in green color. Instead of y squared, now I'm gonna plug 7 minus x squared. Nice. Minus 2 over 7x over 3. Let me have 3 times, no, let's not change 2 over 7 in case we need to factor it out later. I think we do. So let's keep it as 2 over 3 times 7, which is 2 over 21. But again, what if we need to factor out 2 7s? So x and then y cubed in green. That is 7 minus x cubed. Okay, good. dx. Now only left to integrate with respect to x, and it is freaking not easy. Look at this. What the heck is going on here? We have squares, we have cubes. No idea. So the idea is to try to collect those terms together before integrating. I kind of want to collect, let me explain to you. Like, isn't those two terms are the same if I factor out something? Yeah. If I divide the green part by 7, it becomes 1 minus x over 7, right? Inside of the square, of course. So either I multiply the first one by 7, which may be even better. Let's multiply the first one by 7. Then I will have 7 minus x. Oh, not really. 7 minus x squared and cubed. Let's factor out. Usually that works. Let's factor out 7 minus x with the smallest exponent, which is square, and see where it goes. So I do have solution in front of me, but I feel like the solution I see is not natural one. So I'm going to factor out the green part. 7 minus x, but with the smallest exponent, which is 2. Then it will be x minus 1/7 minus 2x 7 minus x, there's a 1 tiny leftover, divided by the 3 times 7, which is 21. Like so. And maybe it will get simplified. That would be nice. Maybe, what if everything gonna cancel out? That would be so nice. So from 0 to 7, 7 minus x squared, keep waiting, and now I have x minus 1/7 minus, I'm thinking, oh, I see. What if I see it this way, this piece and this piece? I can divide by 7 and by 1 more 7. So I want to create 7 minus x, right? To do 7 minus x, how did they do it? Oh, they factor out from one piece x, and from another piece they factor out 7. Oh, that's so annoying. So did they just factor out 7x then? 7x. If I factor out 7, it gives you 1. But then I factor out x, it gives me 1 over x. I don't like that. 7 minus x. Yeah, I definitely need to create this piece to be looking like other pieces, so they collect nicely together. That's the goal. I can see it here. Can't figure out how they got it so nicely. Oh, they created a full square. Oh, of course I cannot figure out, because it's like the most annoying part to do. The full square shows up. I think that's what happened. Yeah, because the final answer is just cube. 2x finally do 21. Oh yeah, so let's distribute everything and see where it goes. 2x over 3, 7 and 1/7 canceled out. Minus minus gives you plus 2x squared over 3 dx. Good. Okay, at least something. Can we collect terms? Yes. So we can collect those two terms, which I'm not sure is a good idea or not. But the whole point, this should actually create some kind of nice 7 minus x or something like this and collect together. I see. Okay, let's just do with a pencil over here. 3/3 minus 2/3, it's 1/3 x. So it's minus 1/7 plus 1/3 x plus 2/3 x squared. Yeah, it looks like a full square or something. Definitely it is. We want to have 7 minus x, so I guess we can, like, this is definitely a square, right? So how do we create full square? Maybe we should like multiply by 7 everything. I guess let me leave it for you to as exercise. It's kind of just too annoying. I can tell you what I got. Maybe I'll post in the comments later, or someone will post what kind of black magic is happening here. And what I see, that it should be integral from 0 to 7. And I have 7 squared over 3. And then you will never believe, but there is an x factored out. So you see those things that factored out. 1 minus x over 7 cubed. So what they did, they divided by x on these parts over here. And then it made 1 minus x over 7. Yeah. Factor it out, I guess. X over 7, like so. Dx. So check if that is the case. I guess we could check by merging it back into the cube and see if it's what's happening there. Okay, after this you use U-substitution. That's the part actually I understand pretty well. As always, algebra is too annoying. But you know, interestingly, you can always use calculator right now. On graphing calculator can actually calculate these integrals, so you don't have to simplify or do anything. Or you can use Wolfram for Desmos or whatever you like. That will already give you the answer. But if you want to know the steps are, I don't like this guy, let's call it U. So we're doing U substitution. U is 1 minus x over 7. Find du, which is minus 17x dx. And I will use this piece as over here, x dx. So solving for x dx will be 7 du. My little box, that's what I call my U-substitution box. I'm plugging the first row and the last row into my integral. It's going to be integral. Well, we need to actually change limits of integration, which is not too bad. It's going to be 0 and 1. Do you know how I know? U is 1. This is x, right? When x is 0, u is 1 minus 0. I'm looking at this very first equation over here. When x is 7, 1 minus 1 is 0. So it becomes 0 gives you 1, and then 7 gives you 0. Don't mess up top to bottom, so you're not supposed to do from 0 to 1 just because it looks nicely. The sign will be wrong, so let math deal with it by itself. If you do from 0 to 1, then change the sign, do the negative in front of the whole integral. Okay, so after this I will have, let's kick out the constants outside. I will have 49 over 3, that's 7 squared over 3, u cube, and dx times x from the equation number 3 is 7 du, U-substitution. So it's going to be 2401 over 3 integral from 1 to 0 u cube du. Correct? Oh, not correct. I can see the mistake I made. Yeah, if you notice, good job. So derivative of 1 minus x over 7 should not have any x. I was too happy that it matched really well. Minus 1 over 7 dx. So this x should be changed using equation number 1, u. So dx is just 7u. So dx is 7 du. That's correct. That was correct. But x have to be changed. Let me erase this yellow part. X have to be changed. We just need to solve for x. If you solve for x, you multiply by -7. So if u is 1 minus x over 7, then 7u is 7 minus x. Then x is 7 minus 7u. That's not y. U. Right? 7 multiplied by 7, 7 here, x moving 7 minus 7u. So that's what we're going to put here, 7 minus 7u. Too bad, my integral was better, but it was not correct. 7 minus 7u du. And now I need to, oh, but 7 is still there, so that piece was correct over here. The 7 is still there. So now I can factor out one more 7. So maybe actually 49 times 7. I think that's what I have here. 49. Okay, looks kind of good, right? Integrate that by distributing. Yeah. 2401 over 3, 1, 0. U cube times 7 minus u to the 4 times 7 du. Kind of wondering, u cube and u4. Yeah, this 7 is already gone actually. So this was not 2401 right away. It only became when I factored out this 0. So I will erase this 0, this 7. I'm erasing this 7. Now it's correct. Because minus u to the 4 du. If you quickly check what is 49 times 7, it is 343. So fix that. 343. And then times 7, it gives you 2401. Finally, you have u to the 4 over 4, right? So 2401 over 3. U to the 4 over 4 minus u to the 5 over 5. What do we plug? Do we go back to the previous variable? No, we don't go back because we changed limits of integration exactly for that reason. So I'm plugging 1 and 0. So 0 goes first, 1 goes next, and that will fix this sign. So it's going to be 0 gives me 0. Then I just need to plug 1 everywhere. It's going to be 2401, 3, 0, 1. And then here it's going to be 1. So 1, 4 minus 1, 5. Do you know the mistake? Well, I kind of did not make it yet. So you plug 0 first, and it gives you 0. Minus you plug 1. So negative, which you could do right away. You could just write down a negative from 0 to 1. And that's where this negative just come out. I told you math will figure it out. So don't be afraid to put the integral from 0 to 1. 1/4 1 minus 1/5 gives you a nice number. What numbers? I'm not sure why I call it nice. 20 at the denominator. And then it's going to be 5 minus 4. It's 1. 120. Blah, blah, blah. You multiply and you get... also 1/4. Yeah, it's good. So it's going to be 2401 over 60. Negative. So it should not be negative. Just like letting you know it wasn't supposed to be negative. I don't know why it suddenly became negative. In my answer, it is not. So some order wasn't good. 4, 3. Oh, I see. Some order did not work well. Something was over here. Oh, I found a mistake. Did you find a mistake? I did. I'm so happy. This negative, I missed this negative. So actually this negative was in front all the time. See, so it should be, when I solved, I forgot the negative sign. Yeah, I made several mistakes. Upsetting for such a good video, but fine. So it was negative all the time. So we can actually write down positive from 0 to 1. Negative all the time, and finally negative got beaten up by the math. So the answer is 2401 over 60. Yeah, we finished this problem. That was much more headache than I expected. Surprisingly, from just algebra. Isn't it funny that you can be so good at like triple integrals and volumes and stuff, and then you stuck with stupid algebra? Like, what kind of magic happened here? I guess when I take a nap, I will look over again and figure it out. Or you figure it out and post below. But thank you for watching and keep working hard.